So the intermediate value theorem depends on a function being continuous, and they tell us that f of x is continuous. They don't say what f of x is, but they just say, hey, rest assured, f of x is some continuous function. So that means we can use the intermediate value theorem to say something on this interval. They're saying, hey, there's some number, we're not going to tell you what it is, but there's some number that if you plug it into the function f, you get 5 out as a result. Okay. That number is somewhere between -3 and 0. So the intermediate value theorem tells us that somewhere on that interval we're going to achieve a maximum. We're going to eventually reach the maximum or the minimum, or somewhere in between. But what they tell us on these endpoints is that at f of -3 we reach 2 for a y value, and at f of 0, the other part of the endpoint, we reach 4. So the intermediate value theorem says, hey, at some point in between these two numbers, you're going to hit 2 and 4 again, or in between or including these two numbers. But the intermediate value theorem can't guarantee that there's going to be anything bigger than that. Look, we know our range of y values is somewhere between 2 and 4. But that's all we can say. We can't say that it's going to reach 5. So no, the intermediate value theorem does not guarantee this conclusion. It could be true, cannot be ruled out. It's possible because since maybe the function f of x, it's at y equals 2 when x equals -3, and it's at y equals 4 when x equals 0. Maybe it's a quadratic function that looks like this. Unless they tell us that, something about the maximum or minimum, or tell us what the actual function is, we can't be sure. The intermediate value theorem can only guarantee that it can be between the lowest and the highest number on that interval. This one's different though because they give us a function f of x, so we can say something about this function. We know it's going to have no maximum because it always increases. And the reason why we're able to jump to this conclusion because with a quadratic, if a is positive, it'll make this u type of shape. And if a is negative, obviously it goes like this. Let's see. So we can say what the minimum is. We can find the minimum really quickly. Maybe we're jumping ahead of ourselves. Out of which of the following intervals does the intermediate value theorem guarantee that f of x has a 0? I'm trying to think if there's a quicker way to do this rather than testing each interval. So for this interval 4 to 5, this isn't a point, okay? It looks like point notation, but this is saying between x equals 4, because they call it an interval. This is between x equals 4 and x equals 5. If we were to plug these numbers into this function, then we get y equals 16 minus 16 makes 0. So y equals 1 for this one. And if you plug in 5, you get 25 minus 20, that makes 5. 5 plus 1 makes 6. So the intermediate value theorem guarantees that we are going to have a number between 1 and 6, including the endpoints. Okay, but it can't guarantee that it has a 0 because the left endpoint and the right endpoint are different by 1 and 6. I think I should go with my original idea. We need to know what the vertex is. Where does a vertex happen? And the quick formula for that with a quadratic is x equals negative b over 2a. So negative 4 over 2a, that makes 2 when you simplify it. So at x equals 2, we reach our vertex, and the y value there is 4 minus 8 makes -4. -4 plus 1 makes -3. So at x equals 2, this function is going to reach its minimum. But that between 4 and 5, the left endpoint is 1, the right endpoint is 6. It's not guaranteeing that f of x has a 0 between those two. So you can proceed in the same fashion with the other questions here. When x equals 1, the dependent variable is -3, -2. And then when x equals 2, we have 4 minus 8, -4, -3. So it means the intermediate value theorem says we're going to go between -2 and -3, but we're not gonna reach 0 because we don't cross 0 on the y-axis. Then if you check this last one, if you plug in x equals 3, then the y value you get is 9 minus 12 is -3, so you get -2. I did that kind of fast though. I want to check me there. But if you plug in x equals 6, you get 36 minus 24, it makes 12, it makes 13. So this one, the lowest value guaranteed by the intermediate value theorem is -2. The highest value is 13. So this interval guarantees that 0 will happen at least some point between x equals 3 and y equals 6.